This is similar figures. Similar figures are figures that have the same shape but not necessarily the same size. Two figures are similar when we know that their corresponding side lengths are proportional and that their angles are congruent. When we know that two shapes are similar, one single wavy line is our similar symbol. So this says triangle ABC is similar to triangle DEF. So let's try to identify some similar figures. Here they're asking which rectangle is similar to rectangle A. We have three rectangles. So first let's compare rectangle A and rectangle B. They both have 4 right angles, so that's a good sign. All their angles are congruent. But the side lengths are not proportional, which means they're not going to be similar. Well, how did I know their side lengths weren't proportional? I set up a proportion. The side lengths for rectangle A are 3 and 6, a width of 3, a length of 6. So I said 3 to 6. For rectangle B, the width to length is 2 to 6. So I set up a ratio 2 to 6. I wanted to see if they were equal and if they formed a proportion. So I set them up equal to each other. I did my cross products here, and I had 6 times 2 and 3 times 6. 6 times 2 was 12, 3 times 6 was 18. They're not equal and they are not proportional sides. Now let's compare rectangle A and rectangle C. Once again, both rectangles have 4 right angles. That's a good sign. All their angles are congruent. And this time the side lengths are proportional. So these rectangles will be similar. So once again, I compared the width and the length of rectangle A, 3 to 6, and the width and the length of rectangle C, 2 to 4. And I did my cross multiplication, 3 times 4 and 6 times 2. 6 times 2 is 12, 3 times 4 is 12. They're equal, and I know that their side lengths are proportional. So I also can see here that if I go from 3 to 2, I'm multiplying there by 2/3. 3 times 2/3 is going to give me 2. 6 also times 2/3 is going to give me 4. So there's a common number there that I'm multiplying by that also shows that they are proportional. So here we're being told that these two triangles are similar, and they want us to find this missing value of x. So I can write a ratio for this smaller triangle. It has a side length on the left of 6 and on the right a side length of 8. In the larger triangle, the side length on the left is 9 and the one on the right is our x. And if they're similar, their side lengths should be proportional. So I'm forming a proportion here, and now I'm going to solve it. So I've got 8 times 9 and 6 times x. So I'm going to get 72 equals 6x. To solve this, I'm going to divide each side by 6, and I get 12. So the missing side length is 12 meters. Let's take a look at one more example here, a real life example. So we have an artist who's drawn a replica of a painting that is on the Berlin Wall. The painting includes a trapezoid. The shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height of the trapezoid in the replica? So here we have a picture drawn out for us. In the original painting, this side here, this base was 15 inches and the height was 12. In the replica, this side, this base is 3.75 inches, and we're looking for this height. So if we know that they're similar, then we can set up a proportion. And since he's creating a replica would be similar. So my proportion for the original painting, I said it had a height of 12 and a base length of 15. In the replica, the height is what we don't know, and the base is 3.75. So they should be proportional if we know they're similar. So I'm going to do 12 times 3.75, and 15 times h. So 12 times 3.75 is going to give me 45, and that equals 15 times h. I'm going to divide each side by 15 to get h by itself, and I get h equals 3. So on the replica, that height is 3 inches.